All right, so we made it to video number 2. Okay, let's begin. Here we want to find the greatest common factor of these 3 expressions. Okay. Um, well, seems like we've done common factor, greatest common factor when we add. Well, let's forget about that. Okay. All right. So what do we notice about these 3 numbers? 3, 21, and 35. Hopefully we notice that they're all divisible by 3. So therefore, that must be part of the greatest common factor because the numbers are divisible by 3. Let me say that a little better. The coefficients of these 3 expressions are divisible by 3. Okay. What about the variable? Well, they have the variable v in common, okay? But in this case, when it comes to the greatest common factor, we're only going to take the smallest power. So in this case, the smallest power is 3 squared. Okay, so this would be the greatest common factor out of these 3 expressions. For number 21, we are actually going to apply the skill out of question 20. Okay, and we are going to rewrite the expression. So if we look at these 3 numbers, these 3 coefficients, I'm sorry, not 3 coefficients, these 2 coefficients, 3 and 15, hopefully we can agree that both of those numbers are divisible by the number 3. The biggest number we can actually divide them by is 3. Well, what about the u's? Well, they do have a u in common. And what about the power though? We take the smallest power. It seems like they also have in common the letter X, and we take the smallest power. We see a square versus a ninth. We take the square exponent. But what about the Y? Oh, this term does not have a Y, but this one does. So it is not common in both, okay? So this will be the greatest common factor, but since we are factoring, we need a parenthesis, and we're going to write 2 terms here. We're going to write 2 terms where when we distribute the greatest common factor into these 2 terms, we will get back the original expression, okay? So let's see. We have a 3 in the greatest common factor. We have a 3 out here, and we need a 3, so I need a 1, so I guess I'll put the 1 here for now. We have a u square, and we need a u to the 8th power. So it seems like we need a couple of more u's, and that will be to the 6th power, because when we multiply, we add the exponents. It seems like we also need a couple of more x's. Here we have x squared, but this term has x to the 9th, so we need 7 more, okay? Now we need a negative 15, so we need to multiply by negative 5 or a minus 5, okay? Minus 5. We have a u square in the greatest common factor. We have a u square out here, and there's no need for no more u's, so therefore we don't need to rewrite that. We have also an x square, and it seems like there's an x square here. There is no more need for x's, but we will need the part of y cubed because that's not part of the greatest common factor. Okay, and that's it. Let's start to apply the same skills for question number 22. Oh, this one's okay. Why don't we tackle example number 23 first before we do 22? Okay, before we do 22 and before we do 24. So let's do 23 first. Okay, because I'm also going to use the grouping technique for this example and for that example down here. So the grouping technique says if I have 4 terms, I can group the first two together, and I can group the last two together. And let's see what comes out of this. Let's see what comes out of this. So, do we notice anything out of the first group? Well, let's see. Let me rewrite that here. So we have 6y cubed plus 21y squared plus 10y plus 35. Okay, so I have this grouped together and then that grouped together. What do I notice out of the first group? Can I factor the first group? Okay, and the answer is 6 doesn't go into 21, but 3 goes into 6 and 21. Okay, I'm also noticing that they both share a y, so I'm going to take a y square. And so then I factor, and I write here a 2y. 3 times 2 will give us 6, and we have y squared. We needed another y. Plus 7, y plus 7. 3 times 7 is 21, and notice that there's no more need for y's. This is enough. What do we notice out of the second group? Out of the second group, we have, it seems like all they have in common is a 5, a positive 5. 5 goes into 10, 5 goes into 35. Why not the letter Y? Because it is not common on both terms, okay? So what do we have here? We have 2y, 5 times 2 is 10, and we need a y, and here just a 7. Okay, I am noticing that this right here and this right here, let me try to use, or let me see, here's a highlighter. Don't we notice something awfully in common? That in very simple non-mathematical terms, isn't this parentheses and that parentheses exactly the same parentheses? So they have that in common. They have that in common. So what would be the other parentheses? What was outside here? What was, I like to say what was left over, okay? After we took only one of those parentheses, or what we took out of what they had in common, then it was left over with the 3y squared and the 5, and then this is done. This is the final answer. This is what we're looking for. We're going to apply this particular skill when I complete example number 22 and number 24. Let's see that in action, okay? Here we're trying to factor 1, 2, 3 terms at the same time. Okay, we cannot do the grouping method yet because we don't have 4 terms. So the first thing we want to do is we want to split the middle term. I don't think I know how to spell middle. How to do that? Okay. In these type of examples, this number, this coefficient is referred to as A, this coefficient as B, and this constant as C. Okay. So what we're trying to do, I guess if we're trying to go back to our topics, we're trying to factor trinomials or polynomials of this form, quadratics. Okay. So there is an A, a B, and a C. The leading coefficient, the linear coefficient, and the constant. So how does this factoring things begin? We must multiply A times C. Well, in this case, that is 3 times 20, which is equal to 60. And then I'm going to list all the factors of 60. 1, 60, 2, and 30, 3, and 20, 4, and 15, 5, and 12, 6, and 10, And that's about it. Wow, 60 has a whole bunch of factors. But which pair do we choose? This is where B comes in. Which pair, these are all pairs, which pair will give us 32? And when I say gives us, which pair will combine, will add up to 32? And I hope you said that this is the only pair that will add up to 32 or combine to 32. So what was that all about? Well, the middle term will become 2y plus 30y. And can we agree that 2y and 30y equals to 32y? Yeah. So we have 3y squared plus 2y plus 30y plus 20. Oh, I see what you're doing now. Now you're going to use the grouping technique. You got it. You got it. Yes, that's exactly what I'm going to do now. I am going to use the grouping technique. And so that's the reason why I said let's complete example 23 first, and then we'll do 20, whatever, 22 and 24. All right, oops, I didn't mean to do that. Okay, so I know this was supposed to be plus. Okay, all right, let's see. What can we get out of these two terms? Out of the 3 and 2, it seems like we only get 1 in common. That doesn't really help us too much, but we can get a y. We can get a y. We can factor out a y, and we get 3y plus 2. And you will notice that out of the second group, the only thing we're going to get out of that will be 3y plus 2. Okay? But what should be out here? That should be a 10. Okay? So that's kind of a technique that I use in this particular example so that I can move a little bit faster. So I know we're going to get out of this group a 3y plus 2. So I just quickly figure out what should be the greatest common factor if we had a 3y plus 2. So here we notice that we have the same parentheses. We don't need 2. We only need 1. But what is the other parentheses? That's right. What was outside or what was left over. However you want to picture that, be able to do that, okay? And that's it. End of the example. That is the answer. Let's practice that one more time using the, in this case, completing example 24, okay? Ooh, before I get too fast, too furious going on here, I am noticing that these three numbers, 2, 4, and 70, they're all divisible by 2. So before I get started, I am going to factor out a 2, before I get this whole show going. Okay, before I get this show on the road. And then what we need to factor is here. Let me take the long steps so that we can practice the skills that we just did in the previous 2 examples. Okay? All right, so let me go ahead and do that. I'm noticing here that A is 1, so A is equal to 1, B is equal to -2, and C is equal to -5. Multiplying A times C, we get -35. I am going to list all the factors of 35. I'm not really concerned with the negative. You'll see how that plays out in a minute, okay? It's 1 and 35. We got not 3, definitely not 2, not 4, but 5 and 7. And that's about it. but we need this to be, or the product needs to be negative. What that means is either the 1 is positive and the 35 is negative, or the 1 is negative and the 35 is positive, or the 5 is negative and the 7 is positive, or the 7 is negative and the 5 is positive. But in order to have a negative, one needs to be positive, the other needs to be negative. One positive, one negative. But, but, when we combine them, when we add them together, that must be equal to -2. And I'm sorry to tell you guys, but the only way to get a -2 is using these two numbers. How? The 7 must be negative. Okay, the 7 must be negative. So what does that mean? Well, I am going to rewrite this as y squared plus 5y minus 7y minus 35. I'm not going to forget about this guy. I just don't need it right now. Okay. Oh, I see what you did. You splitted the middle term so that we can use factoring by grouping. Oh, I see what you're getting at now, mister. I see what you're getting at now. I understand this. Thank you for these videos. Yes, of course, anytime. What I'm noticing about the first two terms is that they have a y in common. I know this is going to work out, so I'm just going to put it y plus 5. And I seem to have to need a -7 out front. So we get y plus 5. We got two of them. We only need one of them. But the other parentheses is y minus 7. And don't forget about this one dude out here. That's why I kind of, highlighted him, put a circle around them so that I wouldn't forget about that too at the very end. And that's the end of that story. Okay. Wow, that was some interesting examples, some good stuff about factoring there. Okay, we got about 11 more problems to go. Let's see what else we get here. More factoring, more factoring. Okay, this is just full of factoring for the next few examples. All right. Huh. Okay. What if, there is a little formula that goes with this, okay? This is very different from example 24 and 22. Notice that there's only two terms. And so that is actually a difference of two squares. A squared minus b squared. And what we like to do is we like to remember this particular factorization, which is a plus b, a minus b. This is referred to as a difference of two squares. Okay. And when we have a difference of two squares, we can apply this rule, or we should apply this rule so that our factoring goes a little bit quicker. So we have 36 minus 49z squared. Huh. I can write this as, oops, I don't know what happened there, 6 squared minus 7z squared. You see what I did here? Instead of writing 36, I wrote it as 6 squared minus 49 z squared as 7z raised to the second power. And so therefore, according to the formula, or the factorization of a difference of two squares, that is simply 6 plus 7z, 6 minus 7z. Okay. All right. And one of the things, to be real technical here, we must follow the order. So in this case, a minus b, a squared minus b squared. The order is a plus b, a minus b. So here, since it was the 6 first, I'm writing 6 first in my two parentheses. Okay. Plus minus 7z. Okay. I did not write 7z first. That was not the way it was written. It was the 6 square first. All right, they want us to factor completely here. We have two terms. Did you notice that they have a 3 in common? Let's take that out. Let's take that out. Did you notice that they also have a u cube in common? Let's take that out. And that's all they have in common. But what's left over? A 1 minus w raised to the 4th power. Oh, okay, I know where this is going. Uh, if uh, if we don't see it, I'm not saying it's okay, but I'm also thinking this is one of those examples that might be pushing the limit, might be going a little bit out there on left field. Let's just see what I'm talking about, okay? This is 3u cubed 1 square minus w square squared. I recognize that this could be a difference of 2 squares, so I wrote it as a difference of 2 squares. So factoring this difference of 2 squares, we get 1 plus w squared, 1 minus w squared. Did you notice that this is also a difference of 2 squares? This is 1 square minus w squared. Final answer. It's 3 cubed, 3 cubed, 1 plus w squared, 1 plus w, 1 minus w. And that's it. How come I didn't factor this out? This is not a difference. This is a sum. And we don't have such formula for sum, only for a difference of 2 squares. All right, let's move on out of here because that's getting a little bit of the complex side and we don't need to confuse anybody. So let's move on out of that and move on to 27. I've noticed that this one is nice and simple. Why? The same parentheses in the numerator and denominator cancels out. The same parentheses will cancel in the numerator and denominator. 9 goes into 4, 9 goes into 36 4 times. This simplifies to 1 over 4. End of that story. End of that story. But what about 28? That story is not so simple. What is this story all about? Well, I'm going to have to factor this. If I don't factor this, I'm not going anywhere. Okay? And don't do this. Don't do this. Don't do that. That is not allowed. That is not allowed in Earth. That is not allowed in Mars. I don't think that's allowed in Jupiter either. Can't do that. That's not how that works. How this works is we're going to have to factor the numerator, factor the denominator, see what kind of parentheses they have in common, and then we'll take it from there. Okay? To do this, let's see. Let's see. We have, let me try to write that out here. W squared plus 5w minus 14. I'm going to try to go quickly on this one. Let's see. Hopefully I don't confuse anybody if I go too quickly on this. 1 times negative 14 is negative 14. Factors, 1 and 14, 2 and 7, not 3, not 4, not 5, right back to 7. That's it. The sum, the sum of the terms must be equal to 5. The only way to do that is to have a 7 minus 2. That is the only way to get a 5. So this factors quickly to w minus 2, w plus 7. How come you did that so quickly? What happened to your factoring by grouping? I know, I took a shortcut. Well, tell us what the shortcut is. If the leading coefficient is 1, if the leading coefficient is 1, then however you split the middle term, those will be the numbers that I use in my parentheses. When can I use this? When the leading coefficient is 1. Okay, well, thank you. Yeah, no problem. Anytime. What about down here? Ooh, I think they want to play some trick with us. I am going to factor out a 3, and then I recognize a difference of 2 squares, and then we can write this as W plus, oh, wow, my handwriting went really crappy there. Let's do that again. Here we have 3, W plus 2, W minus 2. Wow. Wow, making us work for our money, that's for sure. Making us work for our money. Okay, so now that everything is in factor form, I'm going to take those two parentheses out. One in the numerator, one in the denominator. All right, and that's it. That's the best that we could do. Please do not do anything else to this. There is nothing else to do here. It's over. Okay, moving on to number 29. 29. All right, it seems like we got some easy factoring going on. And then, oh, I didn't notice. We got some multiplication. Okay. Why don't I show you how to do this without the need of multiplying, okay? Factor everything out first. Ooh, I was a little cheap on my fraction bars. Factor everything out first, okay? Factor everything out. At the end, you shouldn't need to multiply anything. And I'll tell you why in a minute. All right, so let's see. Okay, I think what we can get out of this is a 9. And then we got, what is that? Oh, 7. We should take out a 7. Sorry. They got it 7. And then that leaves us with 8x minus 9. Here, take out a 2. And then we have an x minus 3. Okay, so what I'm noticing is that once you learn and master factorization, it just shows up in the next couple of examples. So critical, it will be critical for us to be able to factor correctly, okay? Otherwise, we are going to be in a jelly jam for sure. And there is nothing I could do here. There's nothing I could do in the last in the last expression. Let me rewrite that 9 though. But do you notice that we can cancel this entire parentheses out, this other set of parentheses? Okay, we got 7 times 2 over 4. That just comes out as 7/2. So all of this is just 7/2. And the easy way out of that is to factor everything out and then chop off any like parentheses. Okay, hopefully this is making sense. All right. Let's see. We got more. Let's do one multiplication here. One more multiplication, and then we'll take a break. I'll pause, take a breather, and then I'll do the last 5 examples. Okay. Here we go. All right. So there's nothing we could do there, but definitely we can factor this out. That will be 6. 1 and 6, 2 and 3. But we need a -5. Ooh, so I want to be careful. I want to be careful. Because we could get a -5 by doing 1 minus 6. But 1 times -6, it is not +6. So that will create a contradiction. We don't want to do that. So how could this be? How can this be done? Well, the other way to get a -5 is for these two numbers to be negative. And notice that when they're both negatives and we multiply them together, the answer is +6. All right, that was a little tricky, but we got over that. X minus 2, X minus 3. Here, what do we notice? We notice that they have a 4 in common, X minus 2. And what do we have here? Just X plus 1. Okay, being a little tricky there, but that's okay. These two parentheses are gone. Absolutely nothing for us to do here. We cannot just cancel that out. The best that we could say is for X minus 1, X minus 3, X plus 1. That is the best that we can have here. Okay. Alrighty then. What else can we do here? Well, I'm going to take a pause here and then I'll come back. Okay, let's finish this out. Maybe we could get another 40 minutes. Oh, we are now finding the least common multiple of these two expressions. Okay, the least common multiple. Oh, that's a good one right there. Here we have two expressions, 4, 8, u to the 8th, y to the 6th, x to the 4th, and 5y cubed, x to the 7th. Okay, if we look at 4 and 5, let me just do that, 4 and 5. Why don't we list a few multiples of 4 and a few multiples of 5? Okay, so I guess simple enough. 4, 8, 12, 16, 20, 24, 28, 32, blah, blah, blah. We know, right? And for 5, we got 5, 10, 15, 20, 25, 30, 35. Okay, we get the idea, right? But did we notice that as we were writing this out, okay, that eventually these two numbers share a common multiple, or maybe they have multiple ones, but what was the first multiple that they shared together? I don't know why that didn't write, but 20 and 20. That was the first multiple that they both share in common. Okay, so part of the least common multiple will be 20. What about the variables? Well, we need all of them, okay? So we need a u, but this one doesn't have a u. It doesn't matter. We need all of the letters raised to the highest power. Okay, so there's only one u that is raised to the 8th power. We got to take it with us for the least common multiple, Oh, the letter y, they have it in common. Okay, yes, great. But we need the highest power. Oh, okay, so we needed the y to the 6. We also need the letter x, but it needs to be the highest power. So that's the least common multiple, okay? It's a little different from the greatest common, from the common multiple, what is it? Greatest common factor. It's very different from the greatest common factor. 32. Oh, I like these questions, and I also do not like these questions. But let's see if we can get around some testing technique. Here we have a fraction 4v over v minus 1. And we're saying that that is equal to some numerator. But notice that in the denominator, we have now also multiplied by v plus 6. That means that the numerator must be 4v and this times v plus 6. Okay, and that's it. I noticed that the denominator had been multiplied by this term, so the numerator must be multiplied by this term as well. All right, well, that's that. And let's see what we have. Oh, we need to, okay. Well, it seems like we're getting the easiest examples at the very end. I love it. So we're subtracting. We need a common denominator. One of our earlier techniques in adding or subtracting fractions was just to multiply the denominators. So that's what we're going to do here, which this looks very similar to what we did in example 32. If the common denominator is 4a, then I must multiply by 4, and I must multiply by 4. So now we have 20 minus, we needed to multiply by a, we have 3a. And that is as good as it's going to get. 34, another subtraction. Okay, well, what do you think the common denominator is going to be? Well, it will be 2x times x minus 2. Okay, well, it seems that we multiply by x minus 2 here, so we must do the same thing in the numerator. So that becomes 5x minus 2 minus, let's see, here we multiply by 2x, so we must multiply by 2x here. So we have 6 times 2x. I don't know where this came from, but okay. Oh, that's the equal sign, okay. All right, I feel like we can combine some like terms in the numerator. Let's see what those are. So we got 5x minus 10 minus 12x. So we have negative 7x, because I took this negative 12 and I combined it with this 5. So that will leave us with negative 7x's minus 10 over 2x, x minus 2. There we go. We did that. And finally, we get to the last example. I feel like maybe these are not arranged in the right order, but who cares? All right, who cares? Here's the last example, and then we're done. This is the same as 63 over 7. No. Yes. Yes. The rule is if we have the square root of a over the square root of b, we may write this as the square root of a over b. It's a property of radicals. And so what is 6 divided by 7? 9. What is the square root of 9? 3. And this is done. I hope that you found it useful. I think the biggest takeaway out of the second part is definitely the factoring. So I recommend going over your factoring quite, do a good job of going over your factoring. You must complete the review in order to be able to complete the exam, okay? In order to complete the exam, you must complete the review and get a grade of 70 or above, okay? All right, thank you, and hopefully you found this useful. Bye-bye.